So today we're kind of back to not doing really any derivatives. We're just going to learn about the log graph, inverses, all that kind of stuff. And again, this is awesome review for those people that have to write a diploma. So that stuff keeps fresh. And maybe for some of you that didn't quite get it last semester, this is helping you understand it better. Now, so let's just talk about the log function. Now, to find the inverse of a function, and that's y is f to the negative 1 of x, you do two things. Number one, you interchange x for y, and obviously y for x, and then solve the equation y equals. So often after you've done that switching, you've got to get it now y equals, which isn't always easy. Okay, now if you're going to do it graphically, so they just give you a graph, the easiest way is just switch x and y. Right? It is the reflection across the line y equals x. And if you can see on that diagram just below there, that is y equals x. That's 1, 1, 2, 2, 3, 3, 4, 4. It is the place where y equals x. Pretty fitting name for it. Okay, so let's just see how to do this one. Find the inverse of the function y equals 2x minus 6. Now you can pick specific points and graph them. Then switch the points x to y and graph it, and it should be a reflection. The other way is to do it by just using the knowledge of the graph. The negative 6 is my y-intercept, and 2 is my slope. Okay, so here's 1, 2, 3, 4, 5, 6 is right here. Okay, and then the slope is 2 over 1. Always remember that. So we're going to go up 2 over 1. Now you can keep doing a few if you really want to make sure up 2 over 1 that you're getting a good line. You only need 2 points for a line though. Okay, now it should be going through 3 on the x, right? I just want to see that mine's lined up good enough. 3 on the x, 6 on the y. So there's even 2 points there that you can just reverse, because 0, negative 6 would become negative 6, 0, right? This was 0, negative 6 would become negative 6, 0. We've got 3, 0 would become 0, 3. And the point on the mirror will stay on the mirror. Okay, this would be called, this point on the mirror, what do we call it? Invariant point, yeah. The point does not change is invariant. And those, now, what would be the equation of that line? Well, the equation of that line would be Well, let's start and first do our two steps. Step 1 was interchange x and y. So x would equal 2y minus 6. Now I want to get this to y equals. That's step 2. So x plus 6 equals 2y. Then I would divide both sides by 2. I would get 1/2 x plus 3 equals y. Or y equals 1/2 x plus 3, if you want to read it left to right. Okay, so it's saying I should have a y-intercept, a y-intercept of 3, and I should be going up 1 over 2, up 1 over 2. Okay, and that's kind of what it looks like. Since the x and y are switched, okay, the domain and range trade, they switch. Okay, so the domain becomes the range, and the range becomes the domain of the new graph. And f and f inverse cancel each other since they are inverses. And we can play around with this, but I didn't really see where they're going to ask many questions anyway. But if you took the inverse of the function, you always get x. And if you take f of the inverse, you get x. Okay, maybe we'll do one example to kind of show you. We'll do this one. So let's do f of -1. We'll do f of 3. Okay, so f at 3, so that's our x. When on the original function, when x is 3, y is 0. So this would equal f of 0. Oh, f inverse of 0. So then you go with the inverse graph and you say, well, let's put in 0 into the inverse. If you put x of 0 into the inverse, you get 3. Okay, so you end up back where you started. And I don't want to talk about that too much. Okay, now log function is the inverse of y equals b to the x. Okay, now this gets really confusing for students. So I want to first talk about this statement: log b of x equals y, and b to the y equals x. Now these are equivalent. They mean the same thing. Where the inverse occurs is when you go y equals log b to the x. These are inverses. Why are they inverse? A, because they're both y equals. They will be equivalent if one is y equals the log form and x equals the exponent. Okay, those two would be equivalent. They are inverses of each other when you have them both y equals. Okay, and do you see that your base didn't move and the x didn't really move? You're just putting a log in front of it, which makes it the inverse. Okay, now here is some rules that you should remember from last semester or last unit. When you have log b of b to the x, that equals x, and that's only, or that's when x in the reals, right? It's an exponent up there. It can be anything it wants. And then this one too, when you have b log b to the x, this also equals x. But in this case, x has to be greater than 0, okay? Anything in the second level, right here, this is second level of a log. It has to be positive. this entire thing will be positive. Doesn't matter if x is anything. I don't care what x is, you'll never make this thing negative. Okay, exponents can't make things positive or negative. Okay, they could make them inverses, but not positive or negative. And log b to the b is 1, and log b to the 1 equals 0. Now, both of these can be proven because if I change this one to exponential form, that would say, well, b to the 1 equals b. Yeah, I guess that makes sense. And if you change the second one, b to the 0 equals 1. Yeah, that makes sense too. Okay? So remember, these two are equivalent forms that prove. Okay, now here are your two graphs. You know this one quite well. This is y equals b to the x. And this is when b is greater than 1. Remember, it's going to come down the other way if b was a fraction. And this one here is y equals log b to the x. And remember, these are inverses of each other. The proof is in the picture. They are mirror images on y equals x. So this is kind of, we're pretending like this is the first time you've seen this. What do we notice? That if you go to 0 from the right, so here's 0. If we move this way, do you see that a log graph gets closer and closer to negative infinity? Okay, as we get closer and closer to 0, the log graph gets closer and closer to negative infinity. Right? Negative infinity. And then log b to the x, as x goes to infinity from the right, then we would be getting closer and closer to infinity as well. Yep. Okay, now let's just talk about domain and range. For y equals b to the x, the domain is x in the reals. For y equals log b to the x, we have x has to be greater than 0. Okay, you can see that in the graph. For b to the x, all x's are in that domain. You can see for log b to the x, there is no negative x's on this graph. So just now for y equals b to the x, the range is y is greater than 0. For y equals log b to the x, the range is y is in the reals. Okay, so like we said on the last page, that if it's an inverse, domain and range are also inversed, switched, trade. Okay, log b to the 1 equals 0, and log b to the b equals 1. Okay, hopefully nothing new. So common logs are written with base 10. So the two forms log x is actually log 10 of x. Okay, now when you have log 10 to the x, remember there's an invisible 10 there, so you've got 10 to 10 to the x. So hopefully we're thinking x. And this form here, there's also an invisible 10, but when you take 10 log 10 to the x, that also equals x. And I did a lot of proving that in 30-1. Okay, now this one here, remember, first, second, third. Third level can come down to here to be x log b. And remember, there's an invisible 10 there, but it's not written. If there is nothing there, then we're just going to have that assumption. This is the log x plus log y, and this is log x minus log y. Okay. Now the change of base formula, this is important to know if you're ever going to put these into your calculator. How do you solve log? There is no log and then they tell you, they ask you what a is and they ask you what x is. They don't, okay? This is how you'd put this in your calculator. Log x divided by log a. Now, here's something that you may or may not know, but this is the same. You can also write it as 1 over log a over log x. Why not? Okay. Well, because this is the same thing as 1 divided by, or 1 times log x over log a. Hey, if you can't make it complicated, what's used to do in math? That's what I always say. It's like saying 2 is equal to 1 over 1/2. Remember how your world changed when you learned that? Oh, come on. Geez, wasn't that bad. I'm just, maybe someday you'll thank me when they give it to you in this form. You're like, oh yeah, I remember. Thank you, Mr. Trimble. Thank you. Natural logarithms. Okay, so this, we've been doing all this stuff with e, right? So let's keep going with that. Now, ln x is the same thing as log e to the x. And you probably could imagine who invented his own little thing for himself. Mr. Euler, yep. It's like, you know, there's people in car companies, all they do is sit around and they think, what's a cool name for a car? Right? They sit around in committees. They're like, the protege. Yeah, sure, I like it. Let's do the protege, right? Right? There's guys that get paid big money just for names, right? So he knew the right business to be in. Now, what would log e to the x equal? Since you know ln is log e. Should equal x, because it's the same thing as log e to the x, right? And the similar e ln x also equals x, because that's the same thing as e to the log e of x. Okay, so this, if you ever lose your bearings, put in log e, and it'll help you a lot. Okay, guys, I need you back here. Now, ln b to the x, that's log e b to the x. So we know x is on the third level, so it's x ln b. This one is ln x plus ln y. And this one is ln x minus ln y. Morning. Good. Do you need me for anything? Oh, we got a question. Ooh, have I pressed record yet? Yes, okay.
Log e to the x. How does that equal x? Like, you know, you have ln e to the x equals x, and then you have e, so ln x equals x.
Are you right here?
Yeah.
How does this equal x? Okay. I'll do this. E to the log e to the x equals y, right? I'm just going to say it equals something, equals y. Now, if I change this to log form, which it isn't in right now, it's an exponential, right? So base would stay the same, log e to the y equals log e to the x, right? I took all of this exponent and I brought it down here. So you see that x equals y now. This e is a base right now. This is on first, second. Yeah, that's actually low e, and then that's on the same level as e. Oh. Okay, so that's probably the best way I can show you that it works. Nice. I like when I make sense. It's not always, that's for sure. I could say something, but I'm not going to. No, I won't. I am sorry that I have not made sense to you. How's that? Okay. Now, solving, when you solve for x, typically it's not been the exponent. Now I got to get that exponent by itself and out of there. And using the log form does that quite easily. Because if I do not move my base, I will get log 2 of 3 equals x minus 5. And log 2 of 3 plus 5 equals x. Okay, and just to kind of stress one of the rules that this is the same thing as log 3 over log 2 plus 5 equals x. Yep, whatever. Just, you know how multiple choice is, right? Sometimes you got to go find it, and you got to just be aware they're both the same. Okay, this one's not really any different. What I'm going to do is I'm going to change this one up, and I'm going to, instead of log, I will ln both sides. Which is like log e. So by using, whenever you see e, if you can put log e to the both sides, or ln, then that automatically brings that negative x down to the first level, equals ln 1/2, and then I just have to divide by -1 on both sides. And even though this may not be a comfortable way for you to go through things, I'm going to show you later in this unit how you can sometimes save like a half a page of work solving for x, even with doing derivatives, if you can use these. Okay, so it is kind of a time-saving device if you get comfortable with them. Number 3, this one could not be any easier. What does this one equal? 2 equals x. So I kind of gave that one away in number 2. Set it up so it's like that, and then it'll just come right out. This one here I did like 3 different ways. These are always fun to mark because you guys do them many different ways. Now, this one here, if you actually understand that the one rule that Steve just asked about, I can put that 4 up there, right? So do you see how this is just 3 to the 4th equals x? And I use the e log e to the x equals x. Do you see where the x is 3 to the 4th, right? And 3 to the 4th is 81 equals x. Okay, and then I can go through that same one that takes about, 5 steps to do the same one. But if you do recognize that right away, why go through all the work? Okay, but what if you're like, you don't see that one? Why don't we take we'll do this one. Let's take the ln of both sides. Ln e and then that would be 4 ln 3 equals ln x. Okay, now on the left side there, so all I did was ln both sides, brought that exponent up to third level. This ln e is the same log e to the e, so that's 1. So that's just going to be 4 ln 3 equals ln x. Now what can I do with that 4? I can bring it up to be ln 3 to the 4th equals ln x. Now if you have log e on both sides, you can drop it there. So you'll have 3 to the 4 equals x, or 81 equals x. So that would be a longer way to go through that one. But if you recognize this rule right here, then you can just, whatever x is in the exponent there, you can have ln e to the x. Now, let's express as a single logarithm. This is 100% review. I don't even know if we need to do that one. Do we want to do that one? Okay. So, oh yeah, I guess the biggest rule is before you ever start to use the laws, you can't have any coefficients in the front. So this, not good. This, not good. And this, not good. So we're going to bring it up here. This is 1/3. And this is 4. Now if you brought that up as a -4, it would be, well, it wouldn't be wrong. It's just going to be more work. And then these now, this would be log x squared y to the 1/3 all over, oops, not all over, what am I talking about? This all over x minus 2 to the 4th. You recognize it? Okay, so we haven't actually done one where we had to expand using ln, but it's not any harder. So this is ln root x plus ln 5y. Now this here, students do make a common error here, and since all of that is divided, we want to put a set of brackets. So it's going to be divided by these two things multiplied, ln z plus ln 3x plus 1 squared. Okay, and I guess the only thing you can do at this point is you could still break this up, right? And there's an exponent of 1/2 there, so that would be 1/2 ln x plus ln 5 plus ln y minus ln z minus ln 3x plus 1. Or minus 2 ln, because that 2 can come down. Okay, now there's just one more that I want to add in. So you can call this like example 7. And 2 to the x minus 2 equals 7 to the x plus 5. And again, this is really good for those students that still have to write the diploma. The exact answer. So 2 to the x minus 2 equals 7 to the x plus 5. You want to find x. Now, the approximation, y1, y2, find out where they intersect, and you will get x as a decimal. Okay? That's very different than getting exact. Now, always remember that if you get things exponents to the third level, you can bring them down in front. Okay, so you can use logs, you can longs, whatever you want. I'll prefer to use logs, so this would be log 2x minus 2 equals log 7x plus 5. Now, this can be brought down into the front of both of them. So x minus 2, keep it in brackets, log 2 equals x plus 5 log 7. Okay, these two will be distributed. This is x log 2 minus 2 log 2 equals x log 7 plus 5 log 7. Now remember, we're still trying to find x here. So let's isolate x. Let's get all the x logs on the left. We'll get the other numbers on the right. So that would be x log 2 minus x log 7. And then I've got the 5 log 7 that was on that side. I'm going to bring the negative 2 over to be positive 2 log 2. Okay, now I'll take out the x here. Log 2 minus log 7 equals 5 log 7 plus 2 log 2. And to get x by itself now, you just have to divide. So x would equal 5 log 7 plus 2 log 2 all over log 2 minus log 7. Okay, so this is a really good review, and for those taking 30-1, this is just really good to do to get fresh for the diploma, which is coming. You guys have the homework on the bottom of the page, I see, so that's good.